Welcome to qnawire.
Okay, this is question 28.20, where we have two wires that have a current both going in the same direction, and they're separated by a distance of 2a. So in part A of this question, we're asked to consider a point halfway in between these two wires, and we want to know the direction and magnitude of the magnetic field. So the magnitude of the magnetic field caused by a single wire is expressed here, which I've shown up here, where r is the distance from the wire. So first thing, notice that the only factors that this is going to depend on is the magnitude of the current, I, and the distance from the point that we're looking at. So the distance between the point that we were considering and the wire, that's r. So in this case, when the point is halfway in between, we know that I is the same in both cases, so those are equal. And it's going to be an equal distance. It's going to be a distance of A from both of these wires. So the magnitude of the magnetic field coming from both of these wires at this point is going to be the same. So now we have to consider the direction. So using the right-hand rule, for the top wire, if we point our thumb in the direction of the current to the right, then at this point P right in the middle, our fingers are going to curl into the board. So we know that the magnetic field coming from the top wire will produce a magnetic field that's into the page at this point. Doing the same thing for the bottom wire, if we point our thumb in the direction of the current to the right, then at this point here, our fingers are going to be pointing out of the page. So we have a contribution into the page from the top wire and out of the page from the bottom wire. And again, we know that the magnitudes of each of those two magnetic fields are going to be the same because I is the same in both cases and R is the same in both cases. So those are actually just going to cancel out, meaning that there will be no net magnetic field at this point halfway in between. So the answer to part A will be 0. Now, part B asks us about a distance A above the upper wire. So now we have this point up here, that's a distance A above this wire. So again, we already calculated the magnitude from this upper wire here. So I'm just gonna explicitly write that again, where we have magnetic field from the upper wire, and then we're going to want to add that. So this is a distance A from the upper wire, so I'm just going to plug that in here. And now we want to consider the lower wire. It's going to be the same, the current is going in the same direction. So we again are just going to plug this in here, except now this is a distance of 3A, because we have 2A and then another A from this point up here. So if we plug that in, this is going to be the bottom wire. This is 3A, so I'm just going to combine this factor of 2 and the factor of 3. That's going to be 6 down here. So this is going to be the total magnitude of the magnetic field at this point. And we could, if we want to, we can just simplify this. This is just simplifying fractions here into, we'll end up with a factor of 2 on top and a factor of 3 on the bottom if we converted the denominator here into 6 rather than 2. So this is going to be the simplified version of the magnitude of the magnetic field. And if we think about the direction, again, pointing our thumb in the direction of the current, I, using the right-hand rule. So pointing our thumb to the right, that's going to end up with the magnetic field pointing out of the page up here. And it'll be the same from this bottom wire too. If we point our thumb in the direction of the current to the right, then our fingers are going to curl out of the page up here. So when we add these two together, that's just going to result in a magnetic field that has this magnitude pointing out of the page. Now for part C, we essentially have the same thing, except now we're considering another point that's a distance A below the lower wire. So if we go through and calculate the magnitude of everything again, if we think about the magnitude of the magnetic field from this bottom wire, that's actually going to end up being the same as this term here, because it's a distance A from the lower wire. And then the contribution from the upper wire is going to be a distance 3A from this point. So that's going to give us 6A, 6 on the bottom down here. So when we add these up, this is actually just the exact same magnitude as we got in part B. So the answer for the magnitude of the magnetic field is the same in part B as it was in part, is the same in part C as it was in part B. But now thinking about the direction, we want to again use the right-hand rule. So thinking about the bottom wire, if we point our thumb to the right over here, the direction of the current, then our fingers are going to point into the page at this point. And similarly, if we point our thumb to the right up from this top wire, our fingers will point into the page at this point here. So now the direction of the magnetic field down here is going to be into the page, whereas before for part B, it was out of the page.